Awesome. Welcome, everybody. Thank you for joining us today. I'm going to let Ram take it over to kick off this awesome roundtable.
Thank you, Alex. Good morning, good afternoon, and good evening, everyone. First and foremost, I want to thank all of you for taking time out of your busy day to join us for this roundtable, virtual roundtable. We have a talented group of people on this panel, and we're here to talk about a really innovative product from GHSP, a leading automotive solutions company. They've come up with a product that's going to revolutionize a driving experience for electric vehicles. And at Allegro Systems, we were elated at the opportunity to work with GHSP on this project. So when they came up to us and we discussed the challenges and the goals of this project, it was really exciting. And so we were excited to be working with them. So with that, let me go ahead. For Q&A, I just wanted to let you all know so you can post your questions. We have scheduled time at the end of this roundtable to answer those questions, and we'll go through and cover as many of them as we can. And if we are not able to cover some of those questions, we will respond back to you over email or other forms of communication. So once again, thank you. And let me start by introducing this amazing panel. I'll ask each one of them to make a short introduction about themselves, and then we'll get started going into the details. So Larry, can I ask you to first go?
Yeah, I'm Larry Ridge, a chief engineer with GHSP. I've worked in the automotive industry for over 35 years. My experience has been on the propulsion side, powertrain side, and a lot of sensor and actuator development in that space. And for particular to this project, as the chief engineer, I worked on the architecture development, the early architecture decisions, and the relationship building that we had with some of the external organizations that we were working with.
Thank you. Thank you, Larry. How about you, Brad?
Sure. Good morning, everyone. Brad Sanderson, systems engineer at GHSP. Been in the automotive industry for right around 20 years, starting in test and validation and moving into product design and finally into systems. My role in the eVibe was really the systems integration, customer feedback, components, design and development of the system into the vehicle.
Thank you, Brad. Okay, Charlie, you want to go next?
Yeah. Hi, everyone. I'm Charlie Kiefer. I'm a senior FAE at Allegro MicroSystems. I've been in the auto industry also about 20 years, started at Tier 1, now about 7 years in semiconductors. And I was the primary technical contact for GHSP on all Allegro devices that they could use.
Thank you, Charlie. And finally, let me introduce myself. My name is Ram Sathapan. I'm part of our applications and marketing group. So we focus on customer applications and market our products into many of the different applications our products are used in. And I have about 28 years history in the semiconductor industry. And I'm happy to be here. So with that, let's get started. I think first and foremost, all of you would be very interested in knowing what is this product. So I will start out by introducing the product, then we'll go through what are the challenges the GHSP team encountered when they came up with this idea for the automotive electric vehicle space. And then we'll go through, how they figured out what are the components needed, how they worked with Allegro MicroSystems, and how we helped, resolve their challenges and get this product to market. So an exciting journey, and we'll share that with you. And like I said, again, you can post your questions. We'll hold off and answer all of those at the end. Thank you. So with that, if you want to move to the next slide, we can start introductions on eVibe. So Larry, would you do us the honors of explaining what eVibe is?
Yeah, I'll just start with a short story and as a means of introduction. And GHSP is working on a product line for shift-by-wire, and we have expertise in the electronics part of that and the networking and how that is integrated into the vehicle. And one of the OEMs approached us on actually doing that for a specific project and problem that they had, and that required an actuator integration with that. And they had developed a unique actuator with a certain company and wanted to team us up with them. So it started as a collaboration with a large OEM between GHSP and a third partner to bring the electronics and actuation together. And that was a specific actuator type. We call that circular force generator. We'll talk more about that as we go on. And the application there was for an ICE engine, so ICE, and it was cylinder deactivation, where you're going from 8 cylinders to 4 and doing that for the purposes of fuel economy. And this vibration actuator was an attenuation so that when the mode switched of the engine, it would feel smooth to the user in the vehicle. Unfortunately, with the shift in the industry, that was almost 5 years ago when we started that work. Then we shifted to EVs in the industry, and that trend has started. That project got canceled, and so we were looking for places to repurpose that technology, and then went along with the idea of using it in a similar sense as a vibration device, but now we were going to do an emulation device. And the reason was because of the several problems that exist in EVs currently as they're being architected and rolled out. And some of you who has driven them, I drive a hybrid. You might actually have experienced some of these problems. So we have the quietness of the car. Sometimes you don't know that the car is on. If you were, when it's running, you have less engagement with the powertrain. You don't feel the engine RPMs. You don't hear, the exhaust systems, that type of thing. And so you have a kind of a disconnect with the propulsion system. And so we wanted to propose this technology, this actuator technology, in a system that would address those problems. And therefore, we came up with the eVibe product and the eVibe system to do that.
That's interesting. So you kind of recycled, thinking of it as an environmental way, you recycle the product that was meant for combustion engine into electric vehicle.
That's correct.
That's pretty interesting.
Yeah.
So Brad, what would you like to add on top of that about eVibe, especially from your role of integrating that into vehicles in customers, working with your customers?
Yeah, for sure. When we're looking at the eVibe product and we look how that fits like in the market and the development, really trying to provide, drivers and people in the car with a immersive experience, right? The idea here is to create kind of a 3D environment that provides feedback to the driver and the passengers, to create customizable and unique experiences for them. And then that wrap in, Larry didn't really touch, but we also, tried to wrap this into potential safety applications for both, outside and inside the car for alerts and warnings, and really kind of amp up that experience from the EV that's maybe something can bring adoption to the EV market, going from an ICE engine to an EV. There's definitely a much different gap in perception and what people are used to. So this product can really help bridge that gap, and I think bring people something that they're used to, and then expand on that in the market.
Yeah, no, that's a good point. Right? We're all used to driving combustion engines. It's almost 100 years now they've been around, and we're all used to the sound and the feel and the vibrations. Of course, going to an EV. I know my first experience. The first time I drove an EV, I remember coming to a stoplight, and then I suddenly realized that the car shut down. Because it was so quiet, and tried to restart already on car. So I can understand what you're saying. So I think this changes the driving experience for both passengers and driver. So very interesting. Awesome.
Yeah,
let's dig a little bit more into the details. Sorry, Brad, go ahead.
No, very much. Yeah, it's we're definitely not looking at trying to replicate, but trying to bridge that, right? Create some familiarity and stuff into the EV space.
No, that's really good. And I think almost all drivers out there would agree with us that it's something that they would like to see. That quietness is great at certain times, but sometimes in the car, I don't think you want to be that quiet. So awesome. So let's dig a little bit more deeper into this. So if you could, Larry, tell us some of the challenges that you faced when you started this project off. So like what kicked off? And like you said, right, you decided to repurpose it for EV, but you want to give us some background on the product, the challenges you faced for translating this for electric vehicles.
Yeah, I sure will. The partner that we had worked with and brought the actuator technology came from aerospace, and the attenuation they did was for large vehicles, specifically helicopters, so that the riders in the helicopters could have, a real good experience and reduce the vibration levels that were imparted on the passengers in those. But coming from aerospace technology and that large integration, the parts themselves were large and very costly. And so the main challenges that we did in pivoting to automotive with that is how can we cost reduce this and how can we right size it for the application? We were also competing against a linear force technology, which is another way to approach vibration emulation and reduction. But it also has mass challenges, and so we were continuing to try to address those mass challenges by downsizing the unit and right-sizing it for the application. So we're focused on magnet material reduction, which is a primary cost adder in these devices since they're brushless DC motor technology at the base. So we were able to reduce the magnet material by more than 60%, downsize the devices by more than a third as we were going to that. And in doing that, you create another problem then when you have a smaller unit is the electronics integration into that and the packaging for the automotive environment, because you still need the robustness. So we introduced a lot of plastics to address the cost and the weight concerns, and then had to work on the controller integration. And that has to do with the system itself needs feedback. And so there's sensors that are part of that. In this case, they're acceleration sensors and the electronic controls, both of which were separated from the actuator. And so we proposed a solution to integrate all of those into one. So we have the controller integration, the sensor integration, and the actuator integration into one device. And then those devices can be spread throughout the vehicle and maybe communicate with each other. But that creates specific problems around the motor control relative to the weight that you're trying to move at a specific higher response time, and then the sensor integration and getting the magnetic circuits right for the position there. And that's the main challenges that we went forward with.
Okay, interesting. So size, weight, and cost. And I think everyone in every industry cares about it. They want to reduce the size, reduce the weight, and lower the cost. And it looks like you had an interesting challenge coming from aerospace, you had a lot more space to work with to bring that down to fit into the cars.
Yeah, correct. Yep.
Okay. So Brad, I'll switch over to you, and if you can talk about the challenges. Now you're talking about integrating that into vehicles. So can you elaborate a little bit more on what challenges you faced and how you went about addressing those?
Yeah, for sure. If we look functionally at a CFG, like kind of like two of the core things of the product, you basically have two BLDC motors, spinning eccentric mass. So the control of those motors is really key as far as the drive frequency and that to maintain necessary speed to output the force. And as well as we have two eccentric masses that we have to control in space at any given time. So we have some Hall effects from Allegro that we're using, and we've developed a really unique method for the detection that's kind of integrated into the motor magnets and all that. Both of those were kind of really key design challenges. And then as we move into the vehicle, obviously placing these in the vehicle structurally, we look at across the board, we're dealing with a lot of different types of vehicles. So we done a lot of testing across, even current body on frame vehicles like trucks or SUVs, into the unibody market as far as either sedans or small SUVs with success and being able to find locations, basically creating that 3D immersion experience using the CFGs and the eVibe product.
Okay, interesting. Yeah, so completely different challenges than what Larry had to go through in designing the product, and you have to go through in integrating it into the end vehicle. Thank you for that. So I think let's switch over to Charlie. Let's hear something about, Allegro MicroSystems and how they play. So, actually, hold on. Let me go back to Larry. So what made you think of Allegro MicroSystems when you started looking at the challenges and how do you address it?
Yeah, for me, it's quite natural. I've worked, like I said, in the industry for over 35 years. My first experience had to deal with position sensing. And so I worked for a company and we did resistive technology position sensing. And at that time, the industry was converting over to Hall effect. And that was the very first time that I was exposed to Hall effect. And even at that time, then I had a chance to work with Allegro, visit with them to the factory and design center in New Hampshire. And so it's been natural to me. Early on, I've gained that confidence in what Allegro can provide. And then even within GHSP over the last 15 years, on our first generation of electric pumps that we've done, They've done a good job of supporting us on the motor control part of that. We're a brushless DC motor orientation. And so since we had experience with them in this application and the confidence and trust, it was easy for the CFG implementation to look toward them for solutions.
Awesome. Thank you. Thank you for working with us for so many years. Really appreciate it. So Charlie, I'll transition over to you. So Larry and Brad come up with this cool idea, and they've got some challenges of, shrinking things down and trying to fit it in. So they reach out to you. So share with us a story of how this all, panned out when they reached out to you and what you had to do to address their challenges.
Absolutely, yeah. So as Brad mentioned, this project was presented to us as a system that needed precise motor control and then fast reaction times to meet the performance needs that they wanted for eVibe. So we have, our development teams are creating best-in-class sensors and drivers, so to enable this innovation. And so we recommended a couple of products for eVibe. And so we don't just sell chips, we sell solutions. And because of that, we were able to recommend our fast switching 100 volt capable half bridge, the 89500 MOSFET driver. And so this enables them to get that fast speed and be able to change the speed very quickly in order to meet the performance needs that they need. So this part includes, wide input voltage range if there's any kind of different buses they wanted to put it on, or and then also very large robustness on the negative transient voltage protection of our devices. So that's a key selling point of our drivers. So this half bridge enabled GHSP to adapt their custom motor control algorithm that they'd already been working on, so they could reuse that from and downsize from that aerospace base that they already had and keep the same functionality. So we're also a leader in automotive magnetic sensors, as Larry had mentioned. So we're a natural choice to take a look at that. And so we provide a set of our high accuracy APS 12215 Hall latches for tracking those motors and weights. And so those sensors have accurate and symmetric and stable switch points. So that helped, for the full range of automotive environments, helps keep that a very precise system. And as I mentioned, there's two motors in each of these eVibe systems, and each has a dual set of targets. One of the targets keeps track of the speed of the motor, and the other is for the phase difference between the two weights. So that enables them to get the vibration profiles that they're looking for to emulate what they need.
Okay. And I know the 89500, I can remember that. That's one of those small 3x3 millimeter package devices, right? Which addresses perfectly for this size reduction that they are worried about, that they were trying to address in terms of taking a big system and discretes, shrinking them down to a simple system. Okay.
Exactly.
Awesome.
A small package, but can still drive a couple amps of gate drive, so it's very, very strong but small type of package.
Awesome. Thank you, Charlie. Appreciate that inputs on that. So, switching back, let me ask Larry. Right, I know you talked about this. Was there a specific vehicle manufacturer or project that kicked it off, or is this something that you guys drove as an innovative product to bring into the market? You want to give us a little bit more story behind what drove the
Yeah, I sure can. We had both pull and push. So we had a pull from the market, the OEM that we were dealing with relative to the cylinder deactivation system was also then pivoting toward EV and looking for ways to raise their brand awareness for those vehicles, and look toward us at that time when we repurposed this technology to work with them on fitting a vehicle, putting that in place, doing internal demonstrations as they look to roll out their first EV. So, and then we had a push incentive to some of the investment that we had to take care of that, find another alternative for what the collaboration that we had worked on was the third party and to repurpose that technology. So it was a very nice situation where you can have a balance of both in the marketplace. Yeah.
Okay. So I believe this is the Mustang, right? That's the first car that has this technology from Ford. Is this something that you can talk about?
Yeah, we have demonstrated it on the Mustang Mach-E and several other vehicles, some that are confidential for where we are in that development process and rolling it out. But that we've had the Mach-E has been the very first one, and we had good integration in that vehicle. I'd say it was very straightforward. That is a key that we are looking for as we're developing this system, that we don't want to disrupt the current architectures much, but adapt to them, both from the physical packaging into the vehicle as well as integration with the electrical system and the control system that's already in the car. So we will take advantage of the signals that are available there, use those as we're developing the eVibe system. And so on the electrical side, the integration is very straightforward, and the mechanical side, it has also been straightforward for us. Yeah.
Okay. I think I'll transition to Brad on that since you bring that up, right? So Brad, this is a product that can be integrated into new models of cars as they're rolling out, as well as aftermarket. Is that right?
Oh yeah, there's definitely some applications for both. Definitely, we would like to see a fully integrated system because I think it takes the most for the most integration and most use of an eVibe system when we talk about not only the immersion experience, if we want to talk emulation or feedback on a immersion scale, vehicle level scale, but also, as I mentioned briefly, is some alerts if we want to do. Today we have some small shakers in steering wheels or in seats. This can replicate it on a whole vehicle level. It can kind of generate alerts to other occupants in the vehicles and directionality. If it's in an OEM type situation, it can be integrated into other features of the vehicles, such as blind spot alerts or turn signals and those kinds of things, or brake warnings. Or if we go in the autonomous world, it can provide some feedbacks and things in the AVAS industry and applications in that as well. As we transition to the aftermarket, we see some players in this market that the muscle car guys, right? There's definitely, we have some emulation there. We see a lot of sound being developed for aftermarket, for current EVs, and then OEMs or even integration sound, and then they add a vibration to those, really enhance that. But I think in the aftermarket, as far as everybody wants to kind of tune up their vehicles, you're still going to have those people in the market because EVs they're also fast. There's definitely some differentiation that you'd like to happen. And I think this product provides that in both the OEM and the aftermarket market from a customizable standpoint.
I know that's interesting. So every car manufacturer can create their unique experience because you allow them to customize that look and feel. Now that you mention, it's interesting blind spot, because I do remember in my car when I was driving the cross traffic alert, the steering started shaking when it braked automatically for a car passing from behind when I was reversing, and also the blind spot. Yeah, if someone is there, you can feel that. So this technology is something that applies to that, is what you're saying?
Yeah, for sure. I think when on this project, like a development point for me with the addition of tactile feedback, as we see in the market in lots of places, right? Our cell phones, we're starting to see things more tactile. I think we overlook that sense, but today we have so many alerts in vehicles, noise, right? Buzzing, beeping, doors open, that you're kind of overwhelmed. So things like you say, when a blind spot comes up or those sensors, it's hard to differentiate. Or one of the big things I see today is like your backup cameras. When you get too close to a thing, something just all of a sudden starts beeping, or you're parked close to something and it you're going back, but the car beeps because there's something in front of you. So it's like really hard to discern what's going on, where it's like you can have some kind of subtle vibration or pattern that you can distinguish that's not as harsh to the user. Then can give them maybe some better feedback than just having another noise play over the speaker or something like that. So
no, that's
definitely some
interesting.
safety implications.
Two different choices that you allow customization.
For sure.
Okay. Thank you. Thanks, Brett. Coming to you, Charlie. So I know you've been quiet for a while. So I know customer support is very critical. We thank GHSP for being a great customer of ours for a long time. So would you expand to us more on the challenges you faced, or any examples that you can give working with GHSP on this project?
Yeah, for sure. Customer support is everything. That's why I'm here. I'm an FAE. That's what I do is support our customers. And so to have successful partnerships like this, Allegro has to provide support in terms of magnetic simulations, target evaluations, circuit PCB design help, and documentation, all the things that are necessary to make it successful. In this particular project, magnetic simulation is probably the biggest part of it, from my point of view. That's where these latches that have multiple switch point options, and we have a full line of latches, so there's a lot to pick from. So we had to do some simulations, do some testing to make sure that we have the pictures on the screen here of what the targets look like, to make sure you have the proper pole spacing, magnetic strength, spacing from other things in the area, just to make sure you have the optimal performance. So the size, placement, strength of all these components mattered quite a bit. So we went through that a few times and got it right after a few different iterations, and it looks good. So when we spend this time with our great customers, we become trusted partners. They listen to what we say, we listen to what they say, and when they start a new project, they can think of us because they have a good experience. And so it helps both parties because we can show off the latest in semiconductors. They can show us what OEMs are up to and what they're looking for, what the market's looking for. And then we just strive to understand our customers, what their pain points are, and how we can best help them create the innovations that they're doing.
No, that's a very good point you make, right? Collaboration is critical. Partnership and collaboration is important for successful innovation. So let me touch on that. So I will start with you, Charlie. So yeah, you did mention that, right? Collaboration is critical here. And how do you see this collaboration with GHSP in general in terms of projects that you're working on? How it's leading to innovation?
There's some things going on with motor control that we're working on. Some of our FOC motor control things that we've been developing for a while that we've worked with GHSP over the years on, and just continuing with other pump projects and things like that. So it's led to other discussions and talking with other parts of their business as well. So the word spreads that we do good work with this team, and then it helps with other groups within their organization as well.
Okay, awesome. Let's continue that collaboration. So I'll ask Larry and Brad, you also to add your experience working with Allegro and the collaboration and how it's helped you be innovative.
Yeah, for me, I look at it as almost like an extension of your own department. You're working in and you got a crew of people, and it's nice to both position yourself that way with your customer and your suppliers, if you can consider it more like an extended network, and just where it's more natural or easy to do is to pick up the phone and talk with them. Realize that you'll get the expertise and the feedback in an instant, and things that you couldn't do with the capabilities that you have internally. And we've experienced that on this project, both with Allegro and others, and so that is very key for us. And that will also then lead to winning programs. I think it's something it's hard to do on your own. The amount of technology that is needed to pull off the complexity of these systems nowadays is significant, and no one company can hold all that in themselves, and so you have to develop this network in order to be successful. Yeah.
No, very good point. Yep, it's an extension of your network. You get a partnership with your customers and suppliers all working together to solve a problem and bring something innovative. Okay, awesome. So Brad, you would like to add anything on that and the collaboration overall? Any inputs or comments on that?
Yeah, I think definitely building on that collaboration, having a partnership like this allows not only the expansion of that knowledge, right, base and like what our experiences with our customers and Allegro's experience with their customers, but it allows us to maybe focus on products and customize them also with a partnership and a lot of free open thinking, right? So if there's outside of eVibe pumps, we're able to kind of push maybe direction of like, hey, this is what we like to see. This is the way the market's going. Can you have this feature or that feature, right? So that partnership allows us to maybe grow into future development and kind of customize to our needs and our customers' needs and vice versa. So I think that's definitely a great benefit of a close partnership.
Yeah, no, I agree. I think I also see that customer intimacy helps us solve future problems as well. So because now that we've worked, we can think about maybe you're coming up with a new project for the next few years and you're seeing some new challenges. Maybe we can address it in our products. So thank you for that. I'll go back to you, Brad. So I think, as a final question, what do you think of eVibe? It's your product. I know you're very proud of it. What do you think it's going to do for the electric vehicle market in general?
Sure. Yeah, we've kind of discussed that around it. I really think there's an adoption component. I think that's a strong driver, I think, out there is being able to give people something that's normal. The system isn't probably something that's, every day, all day, but it's something that conditions like a big thing with EVs is it on? Is it ready to go? It's a big thing for people new to EVs or haven't experienced EVs yet. You kind of get into it and we're used to like the car starts, it's ready to go. There's kind of a lot of feedback and a lot of that's missing. It's either just an indicator light or it's just not obvious to the user. So this is a way that we can provide feedback and you can immediately know, okay, the car is ready to go, it's in gear, it's ready to travel. So there's a big part there, and that just leads into safety aspect of this and moving around and awareness to people. So there's a big adoption safety portion. Also just fun. Like I say, there is a lot of noise. We can see that in the market. So the OEMs, they can see that, quiet isn't the answer. We can always be quiet, right? You can always turn the system off. EVs can always be quiet, but people perceive that gets, not what they want. So they are doing sound enhancements. I mean, you already have like ANC for road noise and types of stuff. So there's a lot of things going on in vehicles today around noise and sound. So, but what we found is it really, without that tactile feel, it just isn't the same. So this really can provide that feedback and that immersion and make it much more depthful experience for the user. So I think adoption and then, like I say, some of that safety are two things I think that will drive this to market.
No, I agree with you. Actually, I'm pretty sure most drivers of EVs out there probably agree with you that, right, everybody wants some kind of audio, oral, as well as tactical feedback. And I think the market's in early stages for EVs, so I'm pretty sure this is something that'll get adopted and get integrated, become standard feature in all vehicles, all electric vehicles. That'll be awesome. So Larry, would you like to add anything? What your thoughts are on eVibe and what it means for electric vehicles?
Yeah, I just wanted to reiterate the inertia that's in the system now. Over the 100 years we've been comfortable with the combustion engine, and to make the transition, people need to feel connected to the propulsion system, and I think this is an enabling technology for that. As well as the safety aspects. Those are real. When you're in a quiet car near people in a camping, situation or a parking lot or others, I think there are going to be continued regulations along those lines that will need to be addressed by systems like this. And also, you had mentioned that this is early in the EV. I don't think we know all of the architectures that are going to exist. They're evolving. Say the current motor speeds are increasing for the purposes of efficiency and range extension. Those are going to create their own vibration and noise problems that we don't know yet when those continue, and they're going to be needs for this type of system to make the technology work long term.
Yeah, you're right. I think a safety aspect that you guys touched on, both you and Brad, that's important, right? Because a quiet vehicle can surprise many people, including pedestrians, as well as while driving. We may not get a feel for the acceleration. We may be going way too fast. Maybe a vibration will tell us, okay, you've gone way too fast now. Maybe you need to taper down if you're not on a racetrack.
You have to be in tune with your propulsion system. That's right.
That's right. Yep. Yeah, with all windows closed and you won't know. You may be going way too fast. So good point. Safety is also an important aspect that could drive this. So Charlie, coming to you, any comments on the eVibe and future of EV and eVibe?
Yeah, so this project shows the impact that even these somewhat simple but high quality semiconductors can have on a project on a system like this. So our solutions can help make innovations possible in a variety of ways. Like in some cases it's to simplify, some cases it's to use feature up integration to combine things into more concise designs. It just depends on what is needed. If it's robustness, speed, board space, there's many different features or aspects of a design. So collaborating on this type of design or a project like this, to do our part to help with the adoption of these, like Brad mentioned, it's to make people more comfortable with their choices and help move the innovation along.
Yeah, that's what we're here for. We're here to help our customers innovate as best as we can and improve on our products. So thank you for that. So I would like to thank the panel for taking the time. I think that was a great discussion. You answered a lot of good questions and points. Now let's open it up to the audience and see what kind of questions they have. Alex, would you like to take over, or do you want me to go through the questions?
We've got one in there. I'm happy to read, or you can read it.
Yeah, I don't think I can see it yet. Let me see.
Sure.
Oh, Q&A. I'm looking at chat. Sorry, I was looking in the wrong place. Yep. Okay. This question, let's see who it's for. What's the best way to talk to Allegro if we need help with our solutions? Besides EV, what other areas does Allegro play in? So, Charlie, you want to take this? You want me to take it? Let me know.
I can start it. You can finish it, Ram, if you want. So,
Okay.
I'll start with the other areas we do. So we have, a few pillars of focus. Not that we don't focus everywhere, but a few areas that we really have a lot of expertise in. So in the automotive side, it's EVs. We do the inverter systems, DC-DCs, OVCs, and then on the safety side, braking systems and steering systems, whether they're traditional or steer by wire. So those are areas that we do a lot in. Plus, on the non-industrial side, we have teams of people that can have expertise in that as well. So power tools, clean energy, data center, things like that as well. As for the support, we have our rep network around the country that can help support. And then from there, we do have a technical support, helpline basically that our reps have access to. So, our local reps can point you in the right direction and usually gets to someone like me. There's a few of us around, and we can answer those kind of questions.
Yep. The only thing I'll add on that is, we cover multiple different applications. Automotive is our primary focus, both combustion engine. We've been in it for a long time. In electric, like Charlie just mentioned, quite a few vehicles. We've been working on pumps, motors, all kinds of sensing that you can think of, current sensors, position sensors, speed sensors. So there's a lot of magnetic sensors that we supply. And then as far as reaching out to us, you can reach us through the web. You can contact us or through your local, representatives, depending on which region you are. So thank you for that. Any additional questions?
Doesn't look like anything at this time.
Okay. Very good. So I suppose I would like to take the time again to thank the panel and thank the audience for joining us. Thank you, Larry and Brad, really, for answering and, building this innovative product. I'm excited for sure. Look forward to testing it out in a car very soon. Yeah, thank you, Charlie, as well. Yeah, sorry.
Yeah, thank you.
Yeah, thank you, everyone, for joining. Look forward to it.
Awesome. Thank you, everyone.
Just a second.
Okay.
We actually had some come in a minute or so. So we've got, is any SiC or GaN semiconducting component, such as a MOSFET, IGBT, used for motor drive design?
Okay, SiC or GaN used for motor drive design. I'm pretty sure high voltage ones do use them. Who wants to take this from the panel?
Say not in this application, but we do have solutions that can support those if needed.
Yeah. So we see them in the powertrain of a vehicle, electric powertrain, for example, or in the clean energy space where they do use SiC or GaN, FET switches, and we do have products that drive those. We have what we call the isolated high voltage gate drivers, which is different from the one that was mentioned in this product, just like what Charlie said. So yeah, we do have those. They're used mainly in powertrain and in clean energy applications, in power supply type designs. Okay. One more question here. What sensor technologies does eVibe utilize to detect and analyze the vibrations? How does the integration of these sensors enhance the accuracy and reliability? Reliability of the product's performance in various applications. So I think this would go to you, Charlie, right? What sensor technologies are used? And then maybe Larry can add beyond the magnetic sensor, if other sensors are there. Go ahead.
So yeah, it's a Hall-based sensor that's in this system, and it's a latch, so it's going to sense a north and south pole as they pass by, and the sensor enables them to have very precise control of the motor because the precise switching, so very accurate switching points, keeps the timing of the motors very very exact. So that's the main advantage to doing it this way. The switch points are tuned to a specific area to make sure that you get a very accurate 50% duty cycle on the encoder wheel. So
okay.
Basically, other sensors, and depending on the application, we may have different sensor inputs, but it's common for the vibration control to have accelerometer inputs. Some of them can be multiple locations. Some of them can be integrated into our device. which certainly was a packaging and cost advantage for one of the applications. We also would normally have a primary speed input, an RPM sensor from the engine or from the motor itself. RPM, vehicle speed might be another one that we might take, and certainly temperature sensors for environmental to help the control system in general. But we do a lot with sensor integration into devices, the actuation, and then the controls of those together in one unit.
Okay, so you have input from speed sensors into your system, is what you're saying?
Yeah, there are other network inputs that help us optimize the applications. Yep.
Okay, yeah, I can understand. So if you have to respond to the speed with a specific vibration and frequency, or as increase the amount of vibration as speed increases, you need that speed input.
Correct. Yep.
Yeah. Okay, makes sense. Oh, we have one more question. I think this would be for you, Brad. GHSP's eVibe solution, is that specific to Ford or Mach-E, which we saw at the beginning, or is it available to all OEMs? I think you answered this, but please go ahead.
Yeah, for sure. We did do development and work with on a Mach-E, but no, this is applicable to all OEMs. And like I think Larry alluded to, we're working with some other OEMs on trying to develop this system. But yeah, any OEM vehicle, even outside, even in personal mobility or other applications, it could apply. Any place you'd like some tactile feedback. For the application. So no, not a certain OEM specific, definitely open to the market.
Yeah, I would assume so as well. So it's awesome. Let's see. I think that's the last one I see here. Yep, I think that's the last one. So once again, we'll go back to thank you everyone for joining me, taking the time. I really appreciate that, and have a good day.
Yep. You guys take care now. Bye bye.
Thank you. Bye.
So, thank you. Bye bye.